Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we'll be taking a look at what powers are. So, what are powers? Well, simply put, repeated addition leads to multiplication. So, repeated multiplication leads to powers. So what do I mean by this? Well, let's take a look at an example of that. If we add the number 3 4 times in a row, we'll get 12. Now, it's not convenient to write this addition repeatedly, so the shorthand is to write down 4 lots of 3, which results in 12. In the same way, if we do repeated multiplication, we can write a shorthand for the same thing. So 3 multiplied by itself 4 times is 81, and the shorthand way of writing down the number 3 multiplied by itself 4 times in a row is to write the number 3 with a little 4 in the top right. Now, this little 4 is known as the power. Now, there are many other words for this number. There's powers. More often in maths, you'll hear the name indices. And another name for it is the exponent. And one more name is order. All of these words mean the same thing. They're just referring to this number here. So, the little number is known as the power, but there's also a name for the number, the regular number, that is being raised to the power, and this is called the base. So this is base 3 and power 4. Something else to note is that indices is plural. If we want a single power, the singular form of indices is index. Okay, so now that we know what indices are, we're going to be taking a look at laws of indices, some rules that we can figure out to do with them. Okay, so now we'll take a look at the laws of indices. So let's write down an example. If we have 5 squared multiplied by 5 to the power of 4, we can write this out in full as follows. So the 5 squared is the 5 times the 5, and 5 to the power of 4 is 5 multiplied by itself 4 times in a row. And if we multiply all of them together, now we have the number 5 multiplied by itself 6 times in a row. So the equivalent thing we can write down is 5 to the power of 6. So if we take a look at the two powers, since they have the same base of 5, we can simply add those two numbers together. 2 plus 4 gives us 6. So, our first rule of indices, or the first law of indices, is that we can write down a to the power of m multiplied by a to the power of n equals a to the power of m plus n, where a is any base. As long as these two bases are the same, when we multiply them together, we simply add the powers. Now let's move on to another example. Okay, in the second example, we have the same base of 7. Now we're doing division between them. So if we write it out in full, we could write it out like a fraction. So when we do division, with fractions, we can cancel numbers on the top with numbers on the bottom. So if we cancel out 3 number 7s on the top and 3 number 7s on the bottom, we can get a remaining 7 times 7, which is simply 7 squared. So the rule here is that we subtract the powers. So when we divide two bases, we subtract powers. So a to the m divided by a to the n is a to the power of m minus n. Let's take a look at the next one. Okay. In this next example, now we have a power raised to another power. Inside the bracket, we have 2 to the power of 3, which is then being raised to the power of 4. If we write this down in full, something to the power of 4 means you multiply by itself 4 times in a row. Now that we've written it in full, we can then use our previous law of adding powers together, where we can add 3, 3, 3, and 3 to get 12. So, the rule here, we can see that we multiply the 3 and the 4 together to give the 12. So, if we have a power raised to another power, we multiply them together. Okay, so we've seen the first 3 examples of the laws of indices. We have the rule where we multiply the bases together and add the powers. We divide the bases and we subtract the powers. And if a power is raised to another power, we multiply the powers. So that's the end of the first part. In the second part, we'll take a look at some further rules of powers. So, in this second part, we'll be taking a look at rules for negative and fractional powers. So to begin, let's start by writing 3 squared, which we know the value is 9. If we were to multiply by 3 once again, we can then have 3 to the power of 3, which we know is 27. So when we go up the list, we multiply by 3. Let's multiply once more to get 3 to the power of 4, which is 81. So we have 3 squared, which is 9. Multiplying by 3 gives us 3 cubed. Multiplying by 3 again gives us 3 to the power of 4. That's what happens when we go up the list. We multiply by 3. So if we were to reverse that and go down the list, we would divide by 3. So by dividing by 3, 9 divided by 3 will give us 3. And if you look at the powers, 4, 3, 2, the next power is power 1. So you might already know that any number raised to the power of 1 is itself. That's the first rule that we'll write down. Anything to the power of 1 is simply the number itself. But we won't stop there. We'll carry on dividing by 3. So, if you divide by 3, 4, 3, 2, 1, the next power is power 0. And if you keep dividing by 3 on this side, 3 divided by 3 is 1. Now this will work for any base that we pick, so anything to the power of 0 is 1. And we're not going to stop there, we'll carry on dividing by 3. 4, 3, 2, 1, 0, the next power, following the pattern, should be negative 1. 3 divided by 3 is 1. 1 divided by 3 will give us 1/3, or 1 over 3. This is known as the reciprocal of 3. So anything to the power of negative 1 is 1 over that base. And in particular, this is known as the reciprocal of the number. So, any number which has a reciprocal is then 1 over that number. We're not going to stop there, we'll carry on. Divide by 3 again. 0, negative 1. Now we have power minus 2. 1/3 divided by 3 is 1/9. Let's carry on. 3 to the negative 3. 1 over 27. And 3 to the negative 4, 1 over 81. So if you compare these negative powers with their positive counterparts, hopefully you can see the pattern. Our final law of indices will be this. Anything to the negative power, and this n represents any power, is equivalent to 1 over the positive power of that base. So these are our rules for negative powers. So what about fraction powers? So let's start with a symbol that many of you should already know, the square root symbol. This is the opposite of squaring. So if I write down square root 9, you should be able to tell me the result is 3, as 3 squared is 9. So I have a theory that the square root of a number, since it is the opposite of the power of 2, should itself be a power. So what do I mean by this? I mean that the square root of 9 is equal to the number 9 raised to some unknown power. So I'll represent the unknown power with the letter x. So if this is true, then the square root of 9 multiplied by the square root of 9, which is 3 times 3, is 9. Now, let's replace the square root of 9 with the unknown power. And let's replace the regular number 9 with 9 to the power of 1. As we know, anything to the power of 1 is itself. So, using our laws of indices, on the left side, we can see that we should add these two powers together, x plus x, which gives us 2x. So now we have that 9 raised to this power is equivalent to 9 raised to the power of 1. Therefore, we can conclude that the number 2x must be the same as 1. So 2 multiplied by something is 1, that number must be a half. So the square root of a number is equivalent to that number raised to the power of 1/2. Now this theory works for any fractional power. So what do I mean by this? I mean that the cube root of a number, you can do similar working out to show that the cube root of a number is the same as 1/3 of the power, or power 1/3. So square rooting a number is power of a half, cube rooting a number is the same as power of 1/3, and we can extend this rule to any square root, or I should say any root. So the nth root of a number, where we have n before the square root, is equivalent to that number raised to the power 1/n. So this will be very useful when it comes to simplifying powers. So, what did you think of the video? Make sure you give it a like, comment and subscribe if it helped you out. Please recommend to anyone who you think it will help, and I hope to see you in another video. Take care.